So good afternoon once again. Today we're going to start our discussion on machine learning. So let me title this ML, machine learning, and there are many types of machine learning. We're going to first learn about one of the most popular one, decision trees. Okay. So as I was saying, there are different types of machine learning. You have supervised machine learning, you have unsupervised machine learning, you have reinforcement learning. What we're going to study in this course is the supervised machine learning. In supervised machine learning, it's named as such because you already know, you have already in mind what you want to predict or what you want to model. Unlike in unsupervised learning where you have the data and you don't know what to make of the data yet. So for supervised, you have models like decision trees, random forest, support vector machines, etc. We're going to have examples of this, and and we're going to use it in the light of finance. But for our first example, we'll have a generic example. Okay, so let's first load our data. Okay. So let's load the packages first. Okay, library. Pacman, and then let's load tidyverse first. And we will load another let's load that already. Let's load the party package also. Okay, then let's load our data. Let's call it data na lang, no? Data. Sorry, my throat is acting. So how do we load our data? We use the read. This is coming from the read R package. Okay, read underscore CSV. Since it's loaded in our project itself, it will be very easy to access this. Okay, and column names is equal to true. Okay, let's first load our data.
So may typo po, CSV dapat yung sa cardio.csv.
Ay, sorry. Hindi, pangalan natin cardio na lang para mas madali maintindihan.
Ay, sir, I mean sa
yeah, yeah, I saw. Thank you, Stephen. Okay, there. Cardio CSV, call names is equal to 2. Let's run this. And let's, okay, 2,126 columns, rows pala, sorry. Imagine kung 2,126 variables. Rows 2,126 and 22 columns. Okay? So ano yung mga columns natin? Okay, mamaya tingnan natin yung structure niya. So let's first view this. View, cardio. Okay. So these are our variables of interest. I failed to get the metadata, the data about the data. So, but these are physiological and anatomical body measures. LB, I think, is pounds, it's the weight. ACS is a measurement sa heart to lahat, ano? So I'm sorry, I wasn't able to share with you the metadata because it's always important for us to know what these variables are. Okay, maybe next time I'm going to show you. Okay, so this is our variable of interest, NSP. N stands for normal, S stands for suspect, and P stands for pathologic. So this is something to do with a patient or a respondent having heart disease. Okay, based on this, based on this metrics, biometrics, then we would like to know if that person has normal conditions, if he is suspect of heart condition, or he is pathologic, may sakit talaga siya, no? And then ito yung actual, no? 2, ibig sabihin this person is suspected of a heart disease. 1 naman normal, and then 3 pathologic, to my heart condition. Okay, so this is like regression, which is what supervised learning is. We know what our variable of interest is, so we're going to, in this case, model whether using machine learning tools, whether based on our data, a person is normal, based on the data, as I said, suspect or pathologic. So if this was regression, then ano to? Multinomial logistic regression to. Kasi we have 3 cases here, 1, 2, 3. No? So hindi naman siya pwedeng ordinary least squares, hindi siya pwedeng multiple linear regression kasi factor yung natin yung variable of interest, factor yung response variable natin. So this has to take the form of logistic regression. Ngayon, hindi binary kasi tatlo yung tatlo yung levels ng natin ng classifications. So you can either do multinomial logistic regression, okay, or we can do this via machine learning, okay, and which is what we're going to do. So ito yung data natin, let's take a look at the structure of our data. So structure ng data natin. Okay, maybe I'll open another STR, cardio, and then summarize natin din, summary. Okay, let's first take a look at the spelling ko. At the structure, control enter. Okay, there. So this is a special table. It's a table. And we have here the pounds, and then these variables. These are all numeric. And then at the end, we have this variable is also numeric, the NSP. Although dapat hindi siya numeric, dapat factor yan. Okay, and then we have here the attributes. So double sila lahat, no? You know what double means, diba? Sa quantitative yan, sa numerical variable. Okay, pati NSP double. All right, so this is the structure of our data. Yung summary, bibigyan lang sa atin dyan yung minimum, maximum, etc. Now, of course, walang relevance ng NSP na may 5 number summaries. All right. Okay, so what we're going to do now is tingnan natin, class, kung yung variable of interest natin, di ba yung well, we already looked at this, but let me just put it here. Class ni cardio ni NSP. Okay, so numeric siya, no? And we would like to convert that into a factor. Dapat hindi siya numeric. Okay, so let's convert that. So we can rename, we can overwrite this. We can overwrite this, yung NSP na to, and make it just a factor. Or we can create another variable. Mag-create na lang tayo ng bago. So cardio, $sign, let's call it NSP. Factor. Yan. Pwede na yan, no? NSPF. So here, we're creating an object, a column in the cardio object. Okay, and alt minus, then cardio, gawin natin as that factor. Gawin natin factor C, cardio, dollar, NSP. NSP. Okay. So what's happening here? We're introducing a new variable, cardio, sa cardio NSPF, and then it's the factor conversion of the NSP variable as a factor. Okay, so laro natin to. Let's take a look at cardio. Then we have here, my NSPF na tayo dito, no? Yan. Okay, and that one is, let's get the class of that. Class cardio, dollar, NSPF. Tingnan natin. Okay, factor siya. Okay. All right, clear so far, class? If you find me to be going too fast, please interrupt me, no? But I know you can already do this. I know you know this kasi isang term na tayo nagaganito eh, no? Okay. Any questions? Okay, comment naman please kung clear so far. Okay, good. Okay. All right. Tingnan nga natin muna kung ano, yung distribution ng ano natin. Let's see. Table and then cardio and SP. Okay. Let's see the distribution. Oops. Ano yung spelling ko? All right. So we have 1, 1655, no? 2 is 295 and 3. So dun sa sample size natin na 2,000 plus, mas marami talaga yung ano, normal, no? Yung N. 295 were found to be suspect and 3 pathologic, no? May heart ailment, may heart condition. Okay. So in machine learning class, what we do is we do not model all our respondents, all the total sample that we have. So what's done in machine learning is that we have our data. What we do is to split this. We split the data. Okay? Some would split it in 3. So meron tayong tinatawag na training data set. So this is the data set that we're going to use to model, train. Tapos meron tayong test data set. Okay? Others would have another one, validation data set. Depende sa size ng data natin. No? Okay. So why? Why do they split the data? Bakit may training tapos may testing? In our case, we'll just use training and testing. Why do we need to split the data? Because of, this is the main answer, overfitting. Okay? We don't want a model that's overfitted. Okay, kunyari, let me illustrate that. No? Siguro, let's see. Let's get from the internet. Maraming illustration ng overfitting dito. Okay. Overfitting. Ayan, overfitting in machine learning. Okay. Ayan, tingnan nyo to, class. Images. All right. So this is an example of overfitting. Visit natin. Okay. So this is what, YouTube siya.
Hey guys, so what?
So na lang, no? Can you see, class? This is overfitted. Tingnan nyo. Halos, you're trying to model all the points already, no? Yan. This is underfitted naman. Okay. A good, robust model will look like this. ito overfitted to. Why is it called overfitted? Kasi if we now use this model to a new data set, it will not work. Kasi masyado na siyang parang minold, quote unquote, para dun sa specific data set na yun. So what we do in machine learning is we split our data. So yung a certain percentage of that goes to modeling, yun ang training data. And then yung the rest, we will run our model for the testing data to see how our data performs if we split our data. No? You got it, class? Nakuha niya explanation ko? Ini-split natin yung data natin para hindi tayo mag-overfit. Okay? Kasi overfitting is not a good way to model. Tapos natetest pa natin yung model natin. Okay? So that's what we're going to do. And yung percentage usually, I've seen studies na 60-40, 60% yung testing. Minsan I also, but mas nakikita ko 70-30 or 80-20. So 70% yung testing data, or sorry, training data set, and then 30% yung testing data set. Okay, so that's what we're going to do. So paano natin i-split yung data natin? Ito yung si cardio natin, there are 2,126 observations. No? So we can split this into Control-Alt-I. Remember the sample, di ba? Pinag-aralan natin itong function na to, sample, x, size, replace, and probability. So the sample function takes a sample of the specified size from the elements of x using either with or without replacement. So what we're going to do here is papasplit natin yung data natin randomly. Okay? Papasplit natin, kunwari, ilang gusto natin? 2? Okay, sige, pasplit natin into 2. Tapos R will randomly take from the sample for the testing and for the training, and then bibigyan natin yung weight. Ilan yung percent para sa testing, ilang percent para sa training. Alright? So this is what we're going to use. Si sample na function. Okay? In the meantime, let's create and then the name, sabihin natin, ano na lang, sige, group, GRP. So we're grouping our data. Sample. Okay. Ilan yung ano natin, class? Ilan yung sample natin? 2, di ba? 2. Testing and training. Right? And then, ano yung dapat ino natin dito sa ano? Para nakita natin. Ayan, okay. Size. Ano yung size natin? X natin is 2. We're going to split it into 2. The size is ito, di ba? 2126. No? So, what should I write here, class? What should I write there? Anyone? Okay, wag 2126, no? Kasi pang amateur naman yun. Diba? Let's use the n-row cardio. Okay? Comma. Ano pa? Then replace. Ano yung replace? Yung replace, I think I discussed this with you before. Pag sinabing replace, ibig sabihin, when you draw out a sample from your data, kung replace is equal to false, hindi na pwedeng ibalik yun. If replace is equal to true, pwede pang ibalik yun. Okay, so na-maintain yung size ng ano natin, ng data natin. No? So for this one, replace, gawin natin replace is equal to true. And then yung distribution natin will be probability. No? C, ilang gagamitin natin? Relatively okay naman yung size ng data natin. Let's make it 80, 0.8, saka 0.2. Okay, so that will be the size of the distribution. 80% sa isa, kasi 2 sample size to eh. Dalawang sample. So kung 3, so dapat maging 3 yung probability distribution. Alright? So let's see. And then let's print GRP. Tingnan natin yung na lang, yung head ng GRP. Let's take a look at the first 20. Yan. So let's run this. So ang ginagawa natin, ini-split natin yung data natin. Right? End row ng cardio. Okay. So let's run this. Okay, so what happened, class? Okay, nag-generate siya ng random numbers. These numbers. Okay, ilan yun? Dalawang groups yan. Dalawang groups yung generate niya. How do we know which belongs to which? Ito, may numbers, di ba? 1, 1, 1, 1, 2, 1, 1, 1, 1, 2, 2, etc. Question, do we have the same values, class? Do we have the same values? No. Why not? Stephen, why not?
So it's not locked po or random. It's random.
Anong
Not
lock?
really random. Pero hindi po siya
Hindi, tama ka, random
Yeah.
siya, di ba? Random samples nga eh, di ba? So we will have different values. Of course, 1 and 2 lang yan, no? Yan ang x natin, 2. So ang ginagawa natin dito, sabi natin kay R, mag-generate nga siya tingnan natin kung ilan yung length ng length ni GRP. Oh, di ba? 2126. Equivalent to yung cardio. So, ang mangyayari nito, si respondent number 1, he will form part of group 1. Bakit? Kasi 1 siya. So lahat ng 1 dun sa natin, ililink natin dito yan sa cardio. They will form part of group 1, yung sa testing yon kasi 80% yon. Yung number 2 sa yung una training, tapos yung sa mga number 2 testing yan. Alright? So we don't have the same numbers kasi random to. So how do we make it the same, class? So you know what to do there. Paano natin gagawin pareho? Paano, class?
yung set seed po.
Yes, correct. Exactly. Thank you. Set that seed. 1, 2, 3, 4. And pag nag-set that seed tayo, tapos nag-random, kumuha tayo ng random samples, then we will have the same. Run natin to. Okay, you should also have 1, 1, 1, 1, 2, 1, 1, 1, etc. 2, 1, 2, 1, 1, 1. Okay? Sige, paki-comment please if you got the same distribution ng random numbers ng 1 and 2s. Kindly comment please. Yes or no? Sana mag-participate naman yung iba, no? Konti lang pala kayo ngayon. Bigla naging 12 na lang. Kanina marami ako nag-check ng attendance. 11 na lang. How about the others? Okay. All right. Sige. Thank you for your responses. Okay. Now, take note. Hindi pa natin na-split yung data. We only created this object called group. So let's use group in order to split our data. Okay. So we will define our trained data set. Okay. Our trained data set will be from cardio, ba? Isa subset natin. Okay? Subset natin where yung group na object is equal to 1. Okay? So diba, pag nag-subset tayo, we have the row and the column. Okay? So what will happen now? Si cardio is a subset natin so that yung papasok sa train will be group is equal to 1. Okay, kasi 'di ba yung group natin, ito yun ang group natin eh. yung GRP object natin. And then of course, our test data set will be cardio ulit, cardio, subset, group is equal to 2, then no number sa column, which means all the columns should be included. Okay. Ilagay natin dito head. Yan. Kaso lahat yun, no? Malaki to. Huwag na. Tingnan na lang natin yung ano. Kasi yung head, yung train, head, ibibigay niya yung buong yung buong train, which consists of the 22 variables. Huwag na, malaki. Okay, let's run this. Okay, let's see what train consists of. Okay, to train. 17, 18. So pinorate nga niya, 80% thereabouts kay train and 20% yung punta kay test. So if we click this, si train, so si train, subset siya ng cardio na data. Only that it has 17, 18 observations. Okay, parang in-split natin si cardio na data, yung 2,126. 17, 18 of that went to, randomly, was distributed to yung plain data set natin. Tapos si test data set, okay, so that's a test data set, no? 408 observations. So all the columns are present. Okay? Any questions so far, class? Questions? Tanong na lang, hindi kasi kayo nag-ano. Tanong ko na lang kung na-generate nyo to, itong train at saka test, please. Yes or no? Okay, thank you. All right. So meron tayong training data set at saka testing data set. Ito yung gagamitin natin, si training data set. So we're going to use machine learning para i-predict natin kung yung mga individuals na to are classified as N or S or P. So we have a model and then i-compare natin yun sa actual values. Okay, so parang regression din, parang ganun, no? Only ibang methodology yung ginagamit. Okay, and then we're going to use here in this part of the lesson decision trees. Okay, Control Alt I. So let's now, before we do that, let me, okay, let's take a look first at the party package. Dalawang question mark. Party. Taking some time. Okay. Kaya mas maganda dito na lang sa ano. Sa package lang natin tingnan. No? Kasi minsan maraming binibigay na information na hindi naman natin kailangan. So here, party. Okay. Click this. Okay. A laboratory for recursive partitioning. Okay. So this is a package that's used for decision trees. Okay, so let's take a look at the description. The information ba tayo makukuha dito? Wala masyado. Okay, description, a computational toolbox for recursive partitioning. The core of the package is C3, an implementation of regression models into a well-defined theory of conditional trees. All right, so decision tree model, which is akin to regression kasi isang objective nila. Si regression, ang objective is to explain your dependent variable and predict if possible. So ito ganun din. We are predicting kung N, S, o P based on certain yung variables, no? Okay, so balik tayo dito. Okay. Alright, sige. There are many functionalities at may user's guide dito. Let's just take a look at this. So vignettes from package party. Access denied. Okay, so anyway, I leave you guys to read up on that in party package. Okay, so let's go back to our R. Wala tayo masyado nakita kasi yan. Ayaw. Does not want. Ayaw. Okay, balik tayo. Okay, sige. Huling na natin to. Okay, so sa party, may function dyan na gagamitin natin yung C3, which was mentioned a while ago dito. Sige, balikan natin to. Kinalang natin yung C3 here. Here. Conditional inference trees. Okay, so what does this do? It's a recursive partitioning for continuous, censored, ordered, and nominal and multivariate response variables. Okay, so kahit anong klaseng variable, pwede siyang continuous, censored, ordered, nominal, multivariate response variables in a conditional inference framework. So, itong method na to, methodology na to, ang tawag sa kanya, decision trees. So, it establishes nodes in order to split your data into several categories or groupings until it reaches a point na yun na yung conclusion. So, yun, decision tree ang tawag doon. Tapos, ito yung syntax niya. Formula, data, subset, weights, etc. We're going to make use of this. Alright, may isang example siya dito. Okay. So, run na natin. No? Let's create the first object. Tawagin natin 3. Okay, kasi decision 3 to. No? 3.1. This will be our first module. So, ang 3.1 natin, gagamitin natin, lagay ko na lang yung namespace, si party package. No? And sabi ko nga, gagamitin natin yung C3. Okay. Si C3, parang yung regression lang natin yan. Alright? So, dun sa data natin, ang variable of interest natin is yung NSPF. Okay, so, yun ang i-regress natin. So, that's NSPF regressed on, okay, marami tayong variables, but let's just focus on, saan na? So, LB, AC, FN, UC, we have many variables. Okay, but just as a start, let's just focus on itong first three, LB, AC, FN. Okay, so it will be regressed on LB. capital, plus, ano yun?
AC, sir.
AC, thank you.
Then FM.
Plus FM. All right. So this is our model. We're regressing NSPF, the factor, diba? Okay, and then you know what's next, class, is data is equal to cardio. Okay, so if we run this, error in model, anong error ko dito? What's my error? Ako nag-error. Tama naman yung ano natin. Ay, wait. Hindi. Error in model frame before. Okay, dapat ano to pwede to kaso, okay. One mistake I see, pero dapat mag-run to eh. Kasi yung cardio, yun lang naman siya, di ba? Consisting of 2,126 observations. So, saan ako nagkamali dito? Naran ko na ba si party? Let me check kasi library. Let me check kung nag-run si party. Pero naka-check na pala siya. Oo, nag-run siya. Kanina, I opened, di ba? Naka-ano siya. Alright, so C3 function, NPSP, ay, tama, NSPF factor, tama to. LBACFN, data is equal to cardio. Pero hindi dapat yung cardio ang tinetest natin. Ang itetest dapat natin yung training data. Okay, pero dapat mag-run din yung isa. No? Ito, i-run natin class yung training data set natin, consisting of 1,718. We're leaving out of the picture yung the remaining yung testing data. Kasi mamaya, i-run din natin and compare the result. Okay. Oh, bakit wala? Party. Ano, na-load ko na yung party. You see the error, class? Ama naman to, no? No? NSPF. Okay? Cardio NSP. So, okay na yan. Alright, then table. Nakuha na natin yan. Why? Why is it trained? Can see class kung bakit hindi nag-run. LB plus AC plus F.
Sir,
Yes?
I don't know if this is correct, but I removed the quotation marks.
You remove the
And it-
quotation marks?
Yeah, yung sa train po, and it ran.
Ay, oo nga pala. Yeah, oo. Sorry ha. Ito yung mali ko. Oo. Wala pala dapat ano to, quotation. Okay. So, ibalik ko kanina yung cardio. Okay. Yan, nag-run siya, no? Train 1. Okay, but we're not interested in running cardio. We are running the train data set, no? Okay, run. Okay, thank you. Thank you, Stephen. Okay, so we have here now our train data set, and 3.1 is a large binary tree. If you take a look at this, so yan yung laman ni 3.1, no? 3.1, data, responses, etc. So let's see kung ano yung kung pwede natin i-plot si 3.1. But first, let me print train.1. Ay, sorry. Mali na naman yung spelling ko. 3.1. Alright. So, take a look at this. So, it's a conditional inference tree with 10 terminal nodes. What does that mean? Meron tayong nodes na nagsasabi kung if the respondent is NSP, if the respondent is NSP. So meron tayong 10 na final na nodes. So what happens here is, take a look at this. Let's first read the output. Okay. So we are predicting NSPF based on LB, AC, and FM. And the number of observations is 17, 18. Okay. Now you start with AC. This is the flow. If AC is less than 0.00834.028, then criterion 1. After this, if AC is 0.008 or less, then pasok na siya sa criterion 1. Parang conclusion na kagad yun. Pinalan natin si AC, pag less than 0.008 yan, then normal yan. Diba? Criterion is equal to 1, normal. Okay, si 2 yung S yung suspect, si 3 yung pathologic. Okay, so as early as the first line, meron na tayong grouping. Pag greater than 0.008, okay? All right. Then, di ba, ang sabi dito, if AC is less than 0.008, then 1 yun. Otherwise, go to LB. And then check. If LB is less than 136, normal na naman, normal yun. Otherwise, if LB is not less than 136, you look at FM. If FM is less than 0.11111, then conclusion is, anong conclusion? What's the conclusion, class? Okay, tier 1 din, no? If it's less than. However, if it's greater than, okay, titingnan natin yung LB. So parang it's a step process ng classification ng decision tree. But it's quite difficult to address here. Talagang tsatsagain natin kung ano ibig sabihin yan. But what we can do is we can plot this. Mas maganda kung i-plot natin kaysa ganyang no? So how do we plot this? Just the ordinary plot, 3.1, and then i-print natin. Okay. Plot na nga sorry. Plot. Enter. There you go. Alright, may nakita tayong plot dito. So ito na yung solution niya ng model natin. Using the party package, using the C3 function, it's saying that ito yung similar dun sa kaninang tinignan natin. There are 10 terminal nodes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So these are terminal nodes. And then, you notice, pagkatapos nila, wala nang kasunod, di ba? Anong ibig sabihin nito? You take a look first at AC. If AC is less than 0.001, ano mangyayari? If it's less than 0.001, what do we have? Titingnan yung LB, no? Okay? So if LB is ano ba to, equal, less than 136, titingnan naman yung FM. Okay? If FM is less than 0.11, then node 4 siya. If FM is greater than 0.11, node 5 siya. So dito, it tells us the distribution, kung saan mapupunta yung yung particular na na data natin, line nung line na yon ng data. Okay? All right. Any questions here, Gus? Okay, tingnan natin, i-plot din natin to kaso yung mas parang ang hirap kasi intindihin dun, di ba? So we can plot it and then we can specify that the type be equal to simple. Okay, so if we plot this, okay, we'll have another plot. Yan. Okay. Hindi nag-run kanina. All right. So this is the same manifestation. This is the same chart as the previous one. Only this is, let's say, neater and mas madali maintindihan. So, ito, di ba? If AC is less than 0.001, ang gagawin, i-check si LB. You can see the branching out. Okay, so this means that if AC is less than 0.001, check the LB. Okay, if the LB is greater than 136, then may conclusion kagad tayo dito. Okay, it goes to ano siya? Probability na ano siya na normal is 40%. Probability na suspect siya is 0.49. Probability na pathologic siya is 0.10. So, ang pinaka-ano dito, ang winner is number 2. So, ang prediction nitong model na to, that this N314, no? I'm not sure kung N yan is the number of respondents that went here. No? Okay, yung mga N dito. Ilan yung napunta dito sa mga buckets na to, which are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 buckets. 10 buckets siya. Alright? So, pause muna ako. Any questions so far? You have your first decision tree. Feedback please, class, kung okay so far. Okay. All right. Let me close this. Close ko muna ito. Okay, what do we do now? We can modify the decision tree, no? Pwede natin gawin 'yon. So let's do this. Let's copy this. Okay. Kasi yung sa C3, Kumakita yung broom. Okay. So, dalawang titingnan natin. Yung C3, okay, so here, C3. So, recursive partitioning for continuous sensor, ito yung nabasa natin. And then, yung ginamit natin, class, it's just the default. Okay, meron pang iba dito. No? In fact, we can change our plots by using some control trees. No? Okay. So, ano bang sabi dito sa control tree? Yun ang tingnan natin. Okay, ini yung syntax ng ito. Yan. Let's take a look at this. Alright, ito yung syntax ni control tree. So, marami pang pwedeng ipasok, no? C3 control is inside yung C3, no? So, pwede pa natin ma-modify yung yung decision tree based on this. Kunyari, test type. Bonferini ba, Monte Carlo, etc. Minimum criterion. This is the default, 0.95. Minimum split, 20. Tapos may bucket pa, minimum bucket, etc. So the defaults are given here. Okay, so let's experiment on this. Okay, so let's call it 3.1. Baguhin natin, tawagin natin A. 3.1A. So same pa rin yung i-regress natin. Okay, same pa rin. However, anong modification ang gagawin natin? Comma. Pwede natin ilagay yung C3 control. Alright? In fact, we can copy this. Here, bumaba. Hirap. Anyway, sulat na lang natin. No? What are the controls that we can put? Meron tayong test stat, meron tayong test type, tapos meron tayong minimum criterion, kaya ang default 95%. And then, meron tayong minimum split. Kailan yung minimum split means yung minimum value na pwede mag-split yung tree natin is only up to 20. Which means that, kunyari, 80 na lang yung natitira. No? Hindi na natin pwedeng split yon. If we're going to put that as a constraint no, sa model natin. Pero default naman siya, yung mean split is equal to 20. So, ang gawin natin, baguhin natin yan. Okay, so let me copy ito. Ito muna. Control C. Alright, minimum criterion, 0.95. Minimum split, gawin natin Okay. Ibig sabihin kasi ng minimum split na 20. Okay. Minimum yun, di ba? Minimum split. Ibig sabihin, meaning class, ano meaning ng minimum split? Class? It means that in order for a node to split, to be able to split, dapat at least 20 siya. Okay, kasi remember, decision trees, ang model nito is you classify, no? Classify. So the model will create parameters. Just like what you saw, kunyari AC. If AC is this amount, dapat pa ganito na gagawin dyan, no? Okay? Sige, mean split, gawin natin para mas lesser yung, if we increase this, ibig sabihin nun, hindi na basta-basta pwedeng mag-split. Dapat minimum 50 siya. So we know that if mean split is 20, mas maraming terminal nodes yun kaysa mean split equal to 50. Okay? So, what else ang pwede natin ano yun dyan? Minimum criterion, okay, nalagay na natin. Mean split. Okay, I think yun lang muna, no? Alright. So let's run this. Control Enter. Isin ko lang to. Okay, let's run this. Plot na natin. Run. Okay, saan ako nagkamali? Let me check, baka may mali ako sa syntax. Ito muna i-run ko para ma-check natin. Dito ako may error. AC data is equal to train C3 control minimum criterion 0.95 minimum split 50. Okay, yun naman. Anything here, class? Sorry, hindi ko makita. Dapat mag-run to kasi nag-run na yung kanina. Dinagdagan lang natin ng C3 control. Okay. Wait, I think I know. Check na natin yung ano. Tama na yung spelling ko. Bakit nagdi-default? C3 NSPF. Yeah, tama naman. Data is equal to yung train data set natin. Sinawa natin tong, wait. Ay, kung mali. Dapat, I forgot a word here. Dapat may controls dito. Yan. Okay? Controls is equal to. Alright. Okay, kasi yun ang syntax. Dapat may controls. Okay, so let's run this. Okay. So ito na naman, ano? Pero you know what happened? I-print natin si, 3.1a. Okay. Kanina ilan? Ilan terminal nodes natin kanina?
Sir, 10 ata yung bucket, sir.
Kaya pala wala akong marinig kasi yung earphone ko wala. Ilan class?
It was 10.
10? 10 din, pareho din. Okay, so hindi nagbago, no? Pareho lang yung yung 3.1a is also 10. 10 terminals. Ang nabago lang dito is the mean split. So yung mean split hindi masyadong, ito kasi ano naman to this is the default, no? So walang ano yan, walang effect yan. Okay, let's see. Plot nga natin, plot 3.1a type. Type natin simple lang. Okay. One, two, three, four, five, six, seven, eight, nine, 10. 10 din. Okay, sige, hanap pa tayo ng Baguhin pa natin yung natin. Let's see what happens if we change. Okay, let me control out. Copyhin ko na yung okay, let's call this 1B. Okay. Gawin natin yung minimum criterion natin. Okay. 999%. 99.99%. Tapos yung mean split natin, if we increase this class, 500, ibig sabihin nito, no, mas magiging konti yung terminal nodes natin. Kasi hindi na siya pwedeng mag-split. Bawasan muna natin, gawin natin para ang laki ng 500. 200. If our mean split is 200, it means that if the node becomes 195, kasi ang nangyari, di ba, ini-split yung sample natin. Okay? If a particular node becomes 195, hindi na siya pwedeng ma-split. Okay, so andun na yun. Yun na yung classification na yun. No? Okay, let's run this, 1B. Tama, no? Okay. 1B. Run. Okay. What do you notice now? Di ba, linakihan natin yung mean split, di ba? Okay. So, ibig sabihin nun, class, hindi na masyado magiging mas konti na yung classifications natin. Kasi it's like casting your net. If you're casting a bigger net, mas maraming makaklassify, no? Mas maraming mapapasok sa isang classification. When I say classification, I didn't mean the NSP. When I say classification, yung path, kung AC is like this, kung LB is like this, etc. Yung path na sinusunod para magkaroon ng recursive na pag-split ng data natin. All right. So this is more compact, no? Yeah, pareho lang yan. In fact, class, ito, ano tong output na to? So dito sa output na to, yung 1 has a probability of 0.7 and there are more who were classified under this sa node 4 na to. Sa node 5, 100% K3. Ibig sabihin pathologic. So paano nangyari yon? We follow this path, no? P is less than 0.001, LB is less than 136, FM is greater than 112, then pathologic yun. You just trace the path, and that will be, and kaya pathologic kasi 100% dito na pathologic eh. Dito, may probabilities pa. No? Okay? Ito mataas yung probability na normal to. Okay, so that's how you interpret our diagram, our decision tree. Okay. If we do the other one, kung yung sa my type is equal to simple, copy natin to, Control C, Control V, and then ilagay natin type is equal to simple. Maganda yung kasi, itong plot na to kasi makikita natin probabilities. Okay, type is equal to simple, run, yan. You can see here the distribution. Okay? So 5 na lang to, no? Kasi malaki yung natin, minimum criterion. So the bigger the minimum criterion is, the lesser is are the terminal nodes. Tapos ito, dito sa path na to, n is equal to 405. Okay? Ano yung nito? Ano yung, what does this tell us? That 711% malamang normal. So nag-prevail yung normal dito na prediction. Dito, 9% lang yung malamang na suspect. Tapos practically, mga 71, 9, 80, so mga 20% yung pathologic. Alright? So ito na yung predictions ng decision tree based on yung AC, LB at saka FM. Kasi tatlo lang yung pinapredict natin. So based on this, if an individual have that data about AC, LB, and FM, what will happen is that ito yung magiging prediction natin. No? Pag yung individual na yun, let's say, yung AC niya greater than 0.001, okay, in-split din yun, no? If it's less than 0.002 or greater than 0.002, then dito siya sa N. Otherwise, N pa rin to yun. Kasi Y is equal to 0.798. Mas malaki yung yung number 1, which is normal. So we can see here, medyo hindi maganda yung model na to, no? Kasi yung Y niya dito pareho lang, oh. So bakit pa siya nag-split? Kasi nga nag-impose tayo ng minimum criteria, minimum split. Okay. All right. So i-ano natin, class. Let's see kung how effective our model is. We will count kung ilan yung tama, tsaka ilan yung mali. So let's first test our output. Let's use the 3.1. Let's use that first, yung 3.1. And let's see kung ano yung mga predictions niya. Okay? So let's create this object, predict1. Let me just call it P1. Predict1. Okay, siguro to be consistent, P.1. P.1, and then we're going to use the predict function. So predict ng si 3.1, pre-predict niya sa 3.1, and then using the data, train. Okay, there. So we're creating this object called P.1, and then it will predict using the 3.1 model, which is derived from the train data set. No? So let's run this. And then let's get the head of P.1 at yung 10. First 10. All right. So you can see this one, class. Isama natin dito si head cardio NSPF. Okay. So we're going to print this. Head ni P.1, 10. So gawin din natin 10. Compare natin. Okay. Ito si 3.1. No? Take a look at the predictions. Yung una, predict niya as 1. Normal. Ang actual niya, based on the train data set natin, ang actual niya is 2. So here, mali si prediction natin. Then ito, 1, 1, 1, 1. Tama yung mga yan. No? Then pagdating dito, mali-mali na. Naging 3, naging 3, naging 3, naging 3. Okay? So everything here in the next 5, mali siya. Mali yung prediction. Okay. All right. So what we're going to do now is bilangin natin kung ilan yung tamang ilan yung tamang na predict. So let me create a table. Let's call it tab. Okay, I'll call it tab .1. Sige, para pareho dun sa para consistent yung prediction natin. Tab .1. Okay? And then we're going to use the table function. Okay? Table. And then sa table na yan, gamitin natin yung word na predicted. The predicted value will be equal to yung prediction coming from 3.1. Okay? So may 3.1 na model tayo, di ba? Okay, we're creating a table where we plot yung predicted natin. Our predicted values is equal to yung predicted ng 3.1 model natin. Okay, and then yung actual natin, lagay natin dito, actual. Ano yung actual natin, class? What are our actual values? Is equal to? Anyone, please? Hello? Train, di ba? Yung actual natin nasa train, di ba? Right, class? Yung NSPF, yan. Yan, okay? So we're asking R to create a table, call it tab.1, and then we're using the table function. Okay, on the y-axis, yung predicted, which is equal to the predicted value of the model 3.1. And then comma, on the x-axis is your actual. It's equal to the values of the trained variable and SPF. Let's run this. All right, error na naman ako. Okay. Sorry, na-shortcut ko yung Okay. Lobat na ako walang pred, no? Should be predict. Yan, okay. Okay na to, class. Run. Okay, we have now a table. Sige, i-print natin si tab.1. What do we get? Yun. Okay? On the y-axis, we have your predicted. On the x-axis is your, it's almost time, are your actual values. So what do you have here? Predict natin na 1 when yung actual value niya 1. So tama ito. So all the diagonals here are correct. All right? All the diagonals are correct. Predict natin na 2, actually 2 siya, 156. Predict natin na 2 ng model natin na 2, pero actually 1 siya, so 126. So mali ito. So all the off diagonals are errors. Okay? All the diagonals are correct. So let's just i-count natin kung ilan ba yung tama natin. So, kung natin percentage lang ng tama. Okay, sum natin, sum ng, okay, i-add natin itong diagonals natin. Diagonal ng, that's your tab 1, di ba? Tab.1. Okay. Tab.1 to eh. So yung diagonals niya, sum nun, yun yung correct, di ba? And then divided by sum ng tab.1. Isum naman yan in total, in lahat. So if we run this, what happens? So 80%, around 81% was correct. And then of course, yung mali is, okay, copy na natin to, Control C. 1 minus that ratio, okay, will give us, okay, 0.81 ang tama, 0.19 yung mali. Now, i-compare natin to. It's already time, class. I have just a 1 minute na lang, no? Compare natin to, class. Kay 1.a. I-run na rin natin to. Yung table. Okay, in fact, hindi natin kailangan to. Let's put this in parentheses. Okay. And then tab.1a. So this becomes predicted value ng tab.1a. And then this is 1.a. Di ba yung 1.a yung naglagay tayo ng minimum na 50? A. And then A. All right, let's run this. Okay. So, si 1A, pareho lang. Parang may mali ako sa 1.a. Parang pareho lang siya. But kindly check na lang, no? Yung 1B, iba to. So, let's run si 1B. Copyin natin to. I'll preserve that. Control C. Parang may mali ako sa 1.a. Kasi parehong-pareho eh. Hindi dapat, imposibleng magpareho yun. B, unless na yung minimum split natin, wala rin nangyari. So that's actually possible din pala. 1B. Pero tingnan natin tong 1B na ginawa natin ang minimum split natin, 200. No? 1B. 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 Okay, let's see, class. All right. 1, 2, 2. Ay, wait. May mali ako. Saan ako nagkamali dito, class? Rinan ko na ba si 1B? O, meron na akong 1B, oh. Why are we getting the same? Dapat iba yan. Kasi iba yung ano eh. Okay, where did I get wrong here? Let me just end in this class. No? Makita ko lang yung ano yung mali ko. Kasi pareho lang siya. No? Si 1B, si 1A pareho lang kay point A, point 1. So which is suspicious kasi di ba rinan ko si 1A ito? Ito, di ba ginawa kong 0.99 at 9. Palitan ko nga to, class. Let me just change this. Baka masyadong konti lang yung ano. Kasi ang default, di ba, 100. Okay, let me run this. So, ano yung 3.1a? Bago ba? 10 terminal nodes pa rin. Okay. So, let me run yung 1a dito. 122, 126. Okay, run. Okay. 70. Oh, something's wrong, class. Sorry, ah. So, we'll continue with this next meeting. And I'm going to check kung saan ako nagkamali. It looks correct. Eh. Table predicted is equal to 1.a. Well, pero hindi nag-change yung ano, yung confusion matrix natin. Okay, so let me end here. It's already time. So, thank you so much, class. Thank you for your patience. We'll continue this next meeting and then wait na lang for further instructions yung announcement about yung portfolio optimization yung i-record. Okay. All right. Any questions?
Sir, attendance
Yes.
po.
Attendance, sige. Sino to? Who's this?
Organyosa po, sir.
Ganyan siya.
Thank
Okay.
you, sir.
Thank you. Thank you.
Sir, I have a question po
Ay,
about
sorry.
the homework,
Sige. Buti hindi ko pa.
yung efficient frontier.
Oo, sige.
Yeah,
Excuse me.
kasi I was going to do 2016 to 2022 yung data range. Pero yung ibang ETFs ko po, 2017 lang yung pinaka-recent. So is it okay na I cut down
Oh,
some of
i-cut mo
the...
na kasi hindi maglalan yan eh. Magkaka-problem ka.
So okay lang po.
Oo, yeah. Data must be
Okay.
complete. Oo.
Actually, I submitted na po. I was just making sure.
Oo. Tama yun. Tama yung statement.
Okay.
Oo.
Sige, thank you, sir.
Thank you.
Will we be FTF next week po?
Face-to-face tayo next week.
Okay.
Kasi matagal na
Thank you,
tayo
sir.
hindi na, namimiss ko na kayo eh.
Kami rin po.
Oo.
Sige,
Joke
thank you,
lang,
sir.
sige. Thank you, Steven. Thank you. Sige. Okay.